So we're going on page 78 when we're done. Yesterday we solved exponentials that had a common base. So today we're going to solve logs that may or may not have a common base. We may or may not have more than one. So one way to do this, or one situation you can find yourself in, is to have a log on both sides of the equal sign. So a log equals a log, and they would have to have the same base in this situation. So when that happens, we have to condense the logs on each side, which is something that we were not very good at on our test. But we have to be able to condense them appropriately. And then once you have that, and you have a single log on either side, just like yesterday you had to have a single exponential on either side, then you can use the one-to-one property, which says log base b of x equals log base b of y. Notice the bases are the same. If that's true, then x equals y. Okay? So then we solve them once we can take it out of the log. And then here's an extra piece that didn't happen with exponentials, and it is check for extraneous solutions. So do you know what that means? Yes. Okay. So an answer that you get, but when you plug it back in, it doesn't work. So what would have to happen in these parentheses for it not to work? What would be a not okay situation after we substituted it back in? What can't you take the log of? A negative, because look, your log graphs, just like log of x, looks like this, right? Okay. So your domain, your x cannot be what? Negative, or it could be a fraction. Can't be negative. What else can't? What is negative going to? What else is x never going to be? 0. Can't be 0. Can't be negative, right? So if I substitute x back in, and I get 0 or a negative number in here, then that solution I got doesn't work because I can't take the log of a 0 or of a negative number. Does that make sense? So we can't just get x in the end and be like, oh, I'm done. We have to check and make sure that it's going to work. Okay. So let's start with number 2. So on number 2, we have 2 logs, one on each side. They are already condensed for us, so we don't have to do much since this is happening right here, and we have the natural log on either side. Then that means I can just take these pieces out, and k squared minus 4k is going to equal k plus 14. Okay, so then now we're done with the log rules. The rest is algebra. This is what kind of equation? Quadratic. So we set it equal to 0. K squared minus what? 5k minus 14 equals 0. Then we factor that, and we get k plus what? 2 and minus 7. Okay, we all agree with that? That means k is equal to negative 2 and 7. So then we check them. So if I substitute in a negative 2, I'm going to square it so it'll be a positive 4. And then minus 4 times negative 2, so that'll end up being positive. So that's all positive, and that's great. Negative 4 in here will be fine. I'll still have a positive number. And when I substitute in 7 squared minus 4 times 7 would still be positive. Okay, so you have to check negative and positive. It's possible that a positive answer could not work. And then a negative answer is fine as long as you're not taking the log of a negative. That's my answer, and I'm done. Okay, we good with that? Easy enough? All right, so then let's look at number 4. Uh-huh. If you take the log of a negative at all, then you can't do that. It doesn't matter what size. That's what makes it extraneous. Exactly. All right, so now let's look at number 4. We have to condense our logs first. I do not have a single log on both sides. So when I have these 2 logs and they are being subtracted, what happens? Divide. Do I have the log of w plus 6 over the log of 5w minus 3? No, it's a single log base 7, of w plus 6 over 5w minus 3. It doesn't become log over log. Okay, so it turns into a single log. Equals, and then this 1/3, what does it do? Becomes a power, right? So this is going to be log base 7 of 8 to the 1/3 power. Okay, everybody good with all that? Any questions? So we have a single log on both sides. Now I can take them stuff out of the logs, And I will have w plus 6 over 5w minus 3 equals, what is 8 to the 1/3 power? 2, because it's the cube root of 8. Okay? Does that make sense? So now I've got to solve for w. What do I do? Multiply by 5w minus 3. So this will give me w plus 6 equals 2 times 5w minus 3. Make sure that you actually distribute. It's one of the most common ridiculous mistakes that happen. So this will give me w plus 6 equals 10w minus 6. So I'll move my w's to the right and get 9w, 12 over here. So w equals 12 over 9, and then what does that reduce to? 4/3. So then I check it. Well, 4/3 times 5 would be 20/3 minus 3, which would be like 9/3. That would still be positive. That would have to be positive there, so it works and I'm good. Oh my goodness. My pen is possessed. All right. Any questions? All right, let's look at number 5. Do I need to do any condensing before I take it out of the logs? Yes, because I got to take care of this 1/2, right? So the left-hand side's fine. I'm going to leave it as log base 4 of 4p plus 3 equals log base 4 of 16p to the 4th to the 1/2 power. Right? So now I have a single log on both sides. Even though I haven't cleaned up the stuff on the inside, it's fine. I can go ahead and take it out of the log, right? So this will give me 4p plus 3 equals, all right, so this 1/2, since there is no addition or subtraction in here, it gets distributed to both of them. So what is 16 to the 1/2 power? 4. And what's p to the 4th to the 1/2 power? P squared. Okay, we agree with that? Yes? Okay, so it's a quadratic, so what do? Move everything to one side, so I get 0 equals 4p squared minus 4p minus 3. Then I need to factor. Right? So y'all are staring at me like I'm going to factor for you. Factor. Tried by staring at me? Exactly. Staring and guessing is not a good strategy, in my opinion. Okay, that's okay. I'm not rushing you. I'm just looking at what's going on. And make sure once you get something that you think might be right, that you see if it multiplies back to give you that. Because more often than not, the answer to that is no. So I would suggest factoring by grouping, right? So you got that negative 12, and so a negative 6 and a positive 2 would multiply to give me a negative 12, and then these two things would combine to give me the negative 4. And it doesn't matter which order those things are in. Then out of these two, I'd have a 2p come out of there, so that would be 2p minus 3. And then out of there, that would be a 1, which means this is going to factor into 2p minus 3 times 2p plus 1. Okay. Then you check it. 2p times 2p is 4p squared. A lot of times this is where whatever you have just falls apart because your numbers are weird there. Negative 3, positive 1 gives you a negative 3. Okay. Which means that p be negative 1/2 and positive 3/2. Okay, so negative 1/2 going into here would give me a negative 2 plus 3. That's a positive 1, so I'm good. Negative 1/2 to the 4th power will be positive, so we're fine. And there's no way that that would make anything negative, so both of these work. Okay. Everybody okay with all that? Yes? Good deal. All right. So let's look at this one. We need to condense this one. We got a couple things going on both sides here. And so if I start over here, inside these parentheses, like I'm not going to worry about, yes, this is going to become an exponent, but I'm not going to do that yet. Work from the inside out. There's different ways you can do it where it's legal, but at the same time, it just makes it more complicated. So just looking at this right here, if I'm subtracting those two, I can make that a single log that does what? Divides. So just this part right here can become the natural log of 80 over 5. Do you agree with that? Okay. And so then that just looks like an 86. What is 80 divided by 5? 16. And then this 2 can become an exponent up there. We agree with that? So that means I'm going to get the natural log of a plus 1 squared equals the natural log of 16, and then that becomes an exponent up there, to the 3/2 power. Okay, everybody with me so far? Understand how I went ahead and changed that 16 and moved some stuff there? You don't have to, because there's only one thing that you can. It's not wrong if you do, but you don't really have to. So when you have a rational exponent, think about it as two different things. Think about it as 16 to the 3 times 1/2 power and do them separately. Because that 1/2 is the root, and then the 3 would be, a normal exponent. And then, so at this point, I have a single log on both sides, so I can take the stuff out of the logs, right? When I do that, I'll just go ahead and rewrite this again. A plus 1 squared equals, so 16 to the 3/2 power. The 1/2 part of that, what's 16 to the 1/2 power? 4. And then that means I have 4 to the 3rd power, and that would be what? 64. Okay? Everybody with me on that? Did I lose you on that thought process? Yes, because that's what's happening here. You have 16, you can look at it as this, 16 to the 1/2 cubed, or it could be 16 cubed to the 1/2. I mean, this works too, but yuck, right? If you can do the root first to make the number smaller, that's what's happening. So if you can think about it separately, you don't have to worry about 3/2. That makes it weird when you look at it that way. We all good? Okay. So a plus 1 squared, is that a squared plus 1? No. Don't say yes, I'll kick you out of my classroom. Okay, so you're gonna square that, you're gonna end up with a trinomial, right? You get a squared plus what? 2a plus 1 equals 64. Nice try. I'm really not going to kick you out. I'm going to make you stay. That's worse. All right, so everybody good so far? We got a quadratic again, so we move the 64. We get a squared plus 2a minus 63 equals 0. So then we factor. I get a plus something and a minus something, since that's negative. So it would be a plus what? 9 and a minus 7. So a is equal to negative 9 and 7. So then we test it. Negative 9, well, when I put negative 9 in here, negative 9 plus 1 is a negative 8. So that's a fail right there. You with me on that? Now look at the next step. I actually end up squaring it, which would end up making it positive, but this isn't the first step. This is the first step. So in here, if I substituted it in exactly like it looks, it would be the natural log of a negative number, which means it is not going to work. The negative 9 is not okay. The 7, well, that would be positive, and that doesn't do anything over here. So 7 is my only answer, and 9 is one of those extraneous solutions. You just mark it out. You got to show that you found it, and you just mark it out, and you box the other one. Okay, everybody good? So that's what happens if you have a log on both sides. You won't always have a log on both sides, so let's look at what we do with that. So log equals a number, this situation. You condense and isolate the logarithm, if you only have one, rewrite the equation in exponential form, and then solve and again check for extraneous solutions. Bless you. So let's look at number 8. So I have a single log on one side and then I have a number on the other side. So, and it's condensed as much as I can. I can't just take that out of the log because I don't have a log on both sides. I need to rewrite it in exponential form. What is the base of this exponential equation? E. The base of the log, I'm sorry, it's E. So I would have E to what power? The 9th power, because it's the base to the 9th power equals 2A, right? And we're trying to solve for A, so what do? Divide by 2. So A equals E to the 9th divided by 2. And that's it. Everybody good with that? You do not estimate it at 2.7 and try and come up with some stupid number that's just wrong and makes no sense. Okay? All right. So then let's look at number 9. I wrote it in exponential form, but then I had to get A by itself, so I divided by 2. No. What did I skip? The only step I can do is to divide by 2. Okay, yeah. I didn't skip anything. No, I didn't. I didn't do a whole bunch. There's very little to do there. All right, so let's look at number 9. I have a log. I only have one log, and so I need to isolate it. It's not all by itself because this -5 is here. So I just have to move that by adding it to both sides, right? So that I'm left with log base 6 of W plus 7 equals what? 2. So now I have a single log equal to a single number, and now I can rewrite it in exponential form, okay? So the base would be what? 6. So 6 to the 2nd power equals W plus 7, okay? The base to this power equals this value, okay? Every time. So what is 6 squared? 36. So I get 36 equals W plus 7. So W equals 29. All right. Everybody okay with that? Easy enough? I think so. Okay, let's look at number 12. So I have 2 logs, but I can't put a log on either side because this 4 isn't part of a log, so it doesn't really fit in with the rest. So I need to make a single log equal to the number. So I'm going to do that in a couple of steps here. First, I need to take this and make it an exponent, right? And then because I'm adding 2 logs, that changes to a single log where I do what? Multiply. So this is going to be the natural log of 27 to the 1/3 power times x minus 5 equals 4. So you see how I put the exponent on there and multiplied them in one step? Are you okay with that? Okay. Stop me if I lost you somewhere. So what is 27 to the 1/3 power? 3. So this is the natural log of 3 times x minus 5 equals 4. Okay. Yeah, that makes a little bit more sense there, but I didn't want to jump to that step and me lose you. Oh, okay. Got it. All right, so now at this point, even though yes, I could distribute, we can go ahead and rewrite it in exponential form because I have a single log equal to a number. So what's the base here? E. So this is going to be e to the 4th equals, now we can leave it as 3 times x minus 5, or we can distribute. There's one of 2. It doesn't matter because the answers in the end look a little bit different. What would you most likely do in this situation? Distribute? I think I probably would. So, all right, so that means we get 3x minus 15. Just make sure you're actually, like, for real distributing and not just multiplying it times the first thing. I'm trying to get x by itself, so what do I do next? Add 15. So I would get e to the 4th equals 3, oh, sorry, not equals, duh, plus 15. Oh, and you know what we haven't been doing? What haven't we been doing? Checking. Checking for extraneous solutions. We're going to have to back up. Then what do? Divide by 3. So x is equal to e to the fourth plus 15 all over 3. You can make it e to the fourth over 3 minus or plus 5. It doesn't matter either way. So when we check this e to the fourth plus 15 divided by 3, do you think this number, being that this is about 2.7, is going to be more than 5? Yeah, it's going to be more than 5, so it stays positive, so it works, and it's not an extraneous solution. Okay. And then we'll back up and look at the others real quick. So this 29, well here, when I substitute in 29, it all stays positive, so 29 is fine. Okay. And even here, where e like just says well, it's all positive, so it doesn't matter. Like, yeah, it all works. Okay. So then let's look at, we're going to do 13. All right, I have 2 logs, same base that I'm adding, which means it becomes a single log where I multiply. And I really need like brackets around that, because otherwise I don't know if I'm, multiplying the n times the n plus 1 before or after I take the log. So then I can write this in exponential form. I have a single log equal to the number. So this would be 2 to the 5th power equals n minus 3 times n plus 1. So what's 2 to the 5th power? 2 times 2 is 4, 8, 16. 2, 4, 8, 16, 32. Okay, 32. Whew. Equals. All right, so when I multiply this, n times n is n squared. Then outside is n, inside is negative 3n, so that'd be minus 2n, and then minus 3. I have a quadratic here, so I need to set it equal to 0. So 0 equals n squared minus 2n minus 35. Factor. So you get n minus 7. What? Oh, I'm sorry, I was doing it too fast. N minus 7, n plus 5. So n is equal to negative 5 and 7. Are either one of these extraneous solutions? The negative 5, because negative 5 substituted in here, that'd be a negative 8. Can't take the log of a negative number, so that one doesn't work. 7 minus 3 is fine, and then that's positive, so my answer is just n equals 7. Y'all go ahead and start on this next one while I hand out the homework, and then we will work through it. I'm not sure I understand your question. What are you trying to do, a placeholder of? Well, no, because then you're changing the value. You could put plus 0, but you don't even want to do that. It's easy. When you have to multiply it, just think of it as a number. You're just distributing. You're trying to make it harder than it really is. Although, wait a minute, you're trying to multiply. Let's back up, because I think it's division. Yeah, I was thinking, I don't even think there's a cubed in there, so it lost me there. So I've got 2 logs with the same base, and I'm subtracting, so it's division. So log base 2 of c squared over 3c minus 5 equals 2, right? So now I have a single log. I can rewrite it in exponential form, so this will give me 2 to the 2nd power equals c squared over 3c minus 5, right? So 2 squared is 4. I can multiply both sides by that denominator. So I have 4 times 3c minus 5 equals c squared. Okay? Where did I get 2 squared? 2 to the second power equals that. Okay. Everybody else okay with that? All right, so go ahead and finish it up without me talking you through it, and we'll see if we agree. Remember, and when you factor, always double check that what you've got in there is going to multiply back. So negative 2 times negative 10 is a positive 20. And negative 2 and negative 10 is a negative 12, things like that. And since they're both positive, once you put it in here, it's fine because that's going to be squared, and then that'll have to be positive there. Okay? Any questions at all? We good? All right, so go ahead and glue or tape this in now and use the rest of your time wisely.